In this video, we're going to see how the direction of acceleration affects the graphs of velocity and position. We're going to be looking at pictures like this, where a person is sitting in a wagon and shooting a fire extinguisher off in one direction, so that their acceleration is off in the other direction. We can see the direction of the acceleration, the direction of the velocity, and how much time has elapsed. We're only going to look at constant acceleration situations. So the acceleration can be a constant positive, 0, or a constant negative. That means the velocity will be a line, either with a positive slope, a 0 slope, or a negative slope. And that means that the position graph will be part of a parabola, or maybe a line. The line could have a positive or negative slope. So these are the pieces of graphs that we're going to put together to understand the motion. In the first case, we're going to see someone moving to the right and speeding up. Since they're speeding up, the acceleration vector should point the same direction as the velocity vector, which means it should also be pointing to the right, which is our positive direction. So our acceleration graph should be a constant positive. That would lead us to this velocity graph. It's above the t-axis because we are moving to the right, and it's moving away from the t-axis because we're speeding up. And this is our position graph. We can see that we're moving towards the positive direction, and our position graph is getting steeper and steeper, which means we're going faster. And here it is all together. Let's see what changes when we're moving to the right and slowing down. Since we're slowing down, velocity and acceleration should point in opposite directions, so acceleration is pointing to the left, which is our negative direction. That makes the acceleration a constant negative value. We're moving to the right, so the velocity needs to be positive the whole time, meaning above the t-axis, but we're slowing down, so velocity should be getting closer to 0 the whole time. And for our position graph, we should be moving upward the whole time, but our graph should be getting flatter because a flatter graph means we're moving slower. And here it is all together. Now to the left and speeding up. Velocity is pointing to the left, we're speeding up, so acceleration should point the same way, which means to the left, the negative direction. Here's acceleration, a constant negative number, just like we got from the figure before. We're moving left, so velocity should be negative, that is below the t-axis, and we're speeding up, so velocity should be moving away from 0, which means more and more negative in this case. For position, we need to be moving towards the negative, which means left, and we need the graph to be getting steeper because that means we're speeding up. And this is what they all look like together at the same time. Finally, we're going to go to the left, but we're going to slow down. That means acceleration should point in the opposite direction of velocity, so acceleration is pointing to the right, the positive direction. Which means acceleration should be a constant positive number. We're moving to the left, the negative direction, so the velocity should be below the t-axis the whole time, but we're going slower, so velocity should be moving towards 0. And position should be moving towards the negative values, which means the left, but it should be getting flatter because that means we're slowing down. Finally, here it all is together in one screen. Let's summarize. You can't tell whether you're speeding up or slowing down by looking just at the acceleration, but if you look at the acceleration and the velocity, you can. If it points the same way as the velocity, you're speeding up. If acceleration points the opposite of velocity, you're slowing down. If your velocity graph is above the t-axis, you're moving to the right, or whatever the positive direction is in your case. And if it's below the t-axis, you're moving to the left. If your velocity graph is moving away from the t-axis, you're speeding up. And if your velocity graph is moving towards the t-axis, you're slowing down. If your position graph is moving upward, that means the object is moving to the right, or whatever direction is your positive direction in your case. And if the graph is moving down, the object's moving to the left. And finally, if your position graph is getting steeper, then you're speeding up. And if you're getting flatter, the object's slowing down.